So, problem number 21. We have to decide which formula to use. I would give you the interest formulas. You have to know the difference. Make sure if you have anything wrong, you are correcting it as we go through. We only use the E formula if it says continuous. This one does not. So my variables, we have A, P, R, N, and T. It says find the present value. P is principal or present value. It's an amount right now, so we don't know that. To get 600, so my ending amount is 600. After 3 1/4 years, so my time has to be in years, 3 1/4 would be 3.25. 6%, so the rate 0.06. N is the number of times you compound in a year. So daily is how many times?
365.
So then we plug into our formula. A is 600 equals P1 plus 0.06 over 365 is 365 times 3.25 power. And what I would do is just put all this in at once. To move that, to get P by itself, P is multiplied with that parentheses, so you're just going to divide it over. So I think it's easiest just to type everything in. I want you guys to try that and make sure that you get the right answer when you put it in. We are talking about money, so 2 decimal places. So we get 493.70. Did everyone get that, George? Question 22. I think I'm going to go ahead and talk about the whole thing. I don't know why my graph didn't carry over when I opened this. But you have a graph that looks something like this. Domain and range. Domain is going from left to right. This is going to keep going and this keeps going, so eventually it hits everything. So my domain would be negative infinity to positive infinity. Our range is talking about your y, so bottom to top. So starting at the bottom, it's coming from negative infinity. It stops at this y value right here, which was what? 3. Since it hits it, it gets a bracket. Zeros. Zeros are x-intercepts, so we're finding the place where it hits the x-axis. So we can see it hits right here. What's that x value? -3. If you put M2, because it had a multiplicity, that's fine. I didn't ask for the multiplicities, but it wouldn't be wrong if you included them. This one is at 0, and this x value was 1. So those are my zeros. Where is f of x greater than 0? Greater than 0 is above the axis, and I can see this portion is above the x-axis. So we're giving the x's there. It's no equal to, so it's parentheses. We're just giving that interval. So it's starting when x is 0 and ending when x is 1. And those are parentheses because it's not equal to. All right, and then I want maxes and mins. Maxes and mins are just high and low points on the graph. So I can see right here, this point is higher than the ones on either side of it. So there's a couple ways to list it. I think I did function notation. If you did the ordered pair, that's fine. You could say -3, 0. Is that the highest on the entire graph? No, so we just call that a local max. It's higher than the points on each side of it. All right, if I look right here, what's that point? Approximately, x is about 1/2, the y is 3. Okay, it's higher than the points on either side, so that makes it a local max, but it's also the highest on the entire graph, so it's both local and absolute max.
I just called it the absolute max, is that just wrong or?
I would probably take off a half point. So an
So
absolute,
any max needs to have local max, and then if it's the true max, it needs to be absolute.
as long as it's not an endpoint. So, like, if this were an endpoint down here, that would be an absolute min, but it wouldn't be a local because there aren't points on both sides to compare it to. Any other time it would be both. So for my min, the lowest point, this isn't the lowest on the entire graph, but just for surrounding points. This one, it was kind of hard to tell exactly what that was. So it's somewhere between -1 and -2 for the x, so I think I called it -4/3. And your y there looks like about -8 or -8.5. It's kind of hard to tell exactly. So as long as you were close on that one, it is a low point, but not the lowest on the entire graph, so it's just a local min.
So if there's one like that, we just need medians within a half a
Yeah,
point, probably.
just ballpark, and I'll be a little gracious on those if it doesn't work out perfectly. All right, 23 and 24. These were all from the same section. It was like 5.3 back when we did these equations and inequalities. Equations are actually a little bit easier because our strategy is just to get rid of the denominator. Now when we did them, I told you, you don't want to make life harder than it has to be. So we factor everything that we can. So x plus 3 I can't do anything with. X plus 5 I can't do anything with. But over here, what multiplies to 15 and adds to 8? A lot of times we would make ourselves a note at the beginning. What cannot be my answers for x? And why can't x be either of those numbers? It makes the bottom 0. So we just kind of put those there as a check for ourselves. And so then our strategy, since it's an equal to, we talked about getting rid of these denominators. If I want to get rid of a divided by x plus 3, I have to multiply by it. But it's an equation, so we have to take everything. And so then those cancel and these cancel. If I want to get rid of, we still have an x plus 5 on the bottom, so everything has to get multiplied by an x plus 5. And these would cancel and those cancel. And so once I do that, I'm left with 1 times x plus 5 plus 4 times the x plus 3 equals 2. X plus 5 plus 4x plus 12 equals 2. Combine like terms, so 5x plus 17. Subtract the 17, divide by 5, and we get -3. But we already said at the beginning x can't be -3 because if I plug it in, I have 1 divided by 0, and we can't do that. So what's my answer? No solution. No solution. The inequalities were a little bit different. We can't just multiply to get rid of the denominator because in an inequality, if you multiply or divide by a negative, it flips the inequality. Do we know if 2x plus 1 is positive or negative? No, so we wouldn't know whether we flipped or not. Instead, we had to get it set up in a certain way. We had to have a single fraction on one side, your inequality, and 0 on the other. So we had to have just one fraction on one side, 0 on the other. This one's already set up that way. Bless you. So what we did is figure out what makes the top and bottom 0. Those are the only times you can change between positives and negatives. So we get -2 and -1/2. And then we made a sign line. -2 is smaller, it goes on the left. 1/2, and we did test points. So we need a number smaller than -2, so maybe -3. In between -2 and -1/2, so maybe -1, and bigger than -1/2, so maybe a 0. And I am plugging these back into this fraction to decide if it's positive or negative. So if I put in a -3, -3 plus 2 is negative. -6 plus 1 is negative. If you divide two negatives, your answer is positive. If I put in -1, -1 plus 2 is positive. -2 plus 1 is negative. A positive and a negative make. If I put in 0, 0 plus 2 is positive. 0 plus 1 is positive. Two positives are positive. Then we have to decide which ones we need. We wanted less than 0. Less than is negative. So that means I'm looking for this section. Equal to means brackets, but I can't put brackets on both of these. Why?
Because the 1 is equal to 0, like the x equals 1/2 is on the bottom of the equation. So then it can't be 0 because the bottom of the equation can't be 0.
Exactly. The bottom of a fraction can never be 0. So the number we got from the bottom has to have a parenthesis. Always. So my answer is the interval -2 to -1/2. Any number between those two will make that inequality true. -2 gets a bracket because if you plug in -2 you get 0. The 1/2 gets a parenthesis because that makes the bottom 0 and we can't have that. So B, we need to do the same way, but it's not set up correctly. I don't have 0 over here. So first, I'm going to subtract that 2 over. This is like 2 over 1. I'm trying to get a single fraction, so we need a common denominator. So I'm going to have to multiply it by 5 minus 3x on top and bottom. Once we have a common denominator, we can put it together, because it's subtraction, distribute your negative. So we get 6x, 6 minus 10 is -4. 5 minus 3x is greater than 0. So now it has the correct setup. So we set top and bottom equal to 0 to find the numbers for our sign line. We set the top equal to 0, we get 4 over 6, or 2/3. This one, add over your 3x, divide by 5, or divide by 3, and you get 5/3. Then we do test points, so a number smaller than 2/3, maybe a 0. A number in between 2/3 and 5/3, so maybe 1. Then a number bigger than 5/3, maybe 2. And we are plugging them into this fraction. When we have the fraction on one side, 0 on the other. If I put in 0, the top is negative, the bottom is positive. Negative divided by a positive is negative. If I put in 1, 6 minus 4 is positive, 5 minus 3 is positive. Two positives make a positive. If I put in a 2, 12 minus 4 is positive, 5 minus 6 is negative, so that section's negative. Which ones did we want, positives or negatives? Positive. Greater than 0 is positive. So, this is only positive in the middle. No equal to, so that means everything is parentheses. So your answer is just 2/3 to 5/3. If I had done negatives, then we would have had an interval. Negative infinity to 2/3, union 5/3 to infinity. questions on that one? So those inequalities, you might need to look back over. The rules are a little bit different for them. We have to have our sign lines. 25 is more asymptote practice. So we talked about some of these the other day. Last Friday maybe when we worked out some together. Vertical asymptote is just from the denominator. So if you think about when does x squared minus 9 equal 0? Square root plus or minus. So we have two vertical asymptotes at x equals 3 and negative 3. To decide horizontal or oblique, we divide the leading powers of x. If you do x over x squared, one of those cancel and you just get 1 over x. It's only oblique if x is left on top. Otherwise, this is horizontal. If x is on the bottom, that means it doesn't divide evenly, so it's just y equals 0. So anytime x is left on the bottom, it's y equals 0.
So it'll either be y equals 0 or be oblique.
Or it could be y equals a number. If this had been like 3x squared divided by x squared, the x squareds cancel and you would just have 3. So it would have been y equals 3. Alright, so for B, what is my vertical asymptote? 2. Vertical is always x equals, and it's what makes the bottom 0, so x equals 2. To decide horizontal or oblique, if you divide those leading coefficients, x squared divided by x, what happens? It's oblique because x is left on top. So for oblique, we talked about long division. Now thankfully we don't have to do the whole long division, just enough to get the equation of a line, y equals mx plus b. It's like x squared. If you want, you can put a 0x plus 4. So long division is a series of divide, multiply, subtract. So if we divide, what is x squared divided by x? X. Then you multiply. You take x times your x minus 2. And that's x squared minus 2x. We need to subtract that off. So we usually just distributed the negative and then we could add them. Those cancel. 2x plus 0x is 2x. You can bring down your plus 4. Now it's back to the first step. Divide. What is 2x divided by x? 2. And that's all you need. So your oblique is y equals x plus 2. Any questions on that one? So this is all the stuff for graphing polynomial. I always broke it into multiple steps to help you, and I would do that on your final as well. So first step is your degree. Degree is the highest power if it's all multiplied out. So if I did multiply this, we have an x times an x times an x squared. So overall, how many x's do we get? 4. All right, in behavior, remember, we just drew arrows. If it was an even power, it looked like a parabola. If it was an odd power, it looked like a chair. So even power is like a parabola, but what would the negative in front do? Flip it. So this one is both ends pointing down. zeros and multiplicities. This is already factored, so it's just the x-intercepts. What makes x minus 4 equal 0? 4. What about x minus 2? And x plus 2? And since that one was squared, we say it's degree 4, so we should get 4 zeros. We got 4, 2, -2, and -2. So we got all 4 zeros. Bounce or through, that's based off the multiplicity. If it's an odd multiplicity, so this is just 1, 4, 1 is odd, so it goes through. We have 1, 2. 1 is odd, so it goes through. But this one had a multiplicity of 2. We have to hit that place twice. So even bounce. How do we find a y-intercept? Put in 0 for all of your x's. So if you do that, we have the negative in front. -4 times -2 times 2 squared. And we get -32. And then if I have you find all that information, you need to plot it. So we know our graph will start down here and end down here. We're going to touch the x-axis. We have 4, 2, -2. Y-axis at -32. I'm going to count by tens. Alright, so my graph starts down here. We know it's a nice smooth curve, so no zigzags, no breaks. So it has to start down here. At the -2, we bounced. So we're going to hit that place on the x-axis, bounce off. Come back, we have to hit the y-axis here. At these zeros, we go through them. So it should look something like that at the end. Questions on that one? So if we look at B, this one wasn't factored, so we might have to do that in a minute, but we can answer the first few questions. Your degree is your highest power. Since it's all multiplied out, we're just looking for the highest power of x, which is 3. So our end behavior is based off that degree. Since it's odd, it looks like a chair. We don't have a negative in front, so it doesn't flip. So our end behavior is down up. It's going to start down here and end up here. Alright, zeros. So if we look at this, we could factor out an x squared. So if we set each of those equal to 0, just the plain x in front is 0, but because it's squared, the multiplicity is 2. And if you set x minus 4 equal to 0, you get 4. Alright, then we look at if the graph goes through or bounces. So that's based off multiplicity. At 0, the multiplicity is 2. 2 is even, so it will bounce. At 4, the multiplicity is 1. 1 is odd, so it will go through the 4. And last, if you put in a 0 for all of your x's, you just get 0. We hit the x-axis at 0 and 4. Y-axis at 0. Starting down here, we're going to bounce at the 0, so we hit it and come back down. And then you have to go through this one. And you can check at the end it matches the end behavior we set. questions on that? So, last couple. We talked about one-to-one when we were finding inverses. A function has to be one-to-one in order to have an inverse. One-to-one means y doesn't repeat. So if you're looking at a graph, it means it passes the horizontal line test. Something like this, where if you drew horizontal lines, it only hits the graph one time. Something like an x squared. Those are parabolas, and if you have something squared, we know it would not pass the horizontal line test, so it would not be one-to-one. So there are different options. You could, think about what the graph would look like. Things that we talked about would make it not one-to-one, absolute values, because it's a v, or when it has an even power, so an x squared, x to the fourth, both ends are pointing the same direction, those are never going to be one-to-one. When all the powers are odd, that does work out. We think about this one, it's going to be like a chair, and so that would be okay. So this one is one-to-one, which means an inverse exists. What if I had said my function was x squared plus x minus 4? Would that be one-to-one? No, because of the square. So that one would be not one-to-one, so that means there is no inverse. And the idea is inverses flip x and y. And so if you have a place where the y's repeat, when you find the inverse, x would repeat and it wouldn't be a function. Last one, finding the inverse. So remember, steps to finding the inverse. First thing we did was change f of x to y. So my equation is just y equals 3x plus 2 over x minus 1. Second thing we did, switch x and y. So my y becomes an x, both x's become a y. We solve for y. So if I'm trying to get y by itself here, we can multiply over the y minus 1. You need both terms with the y on the same side, so we could subtract over the 3y. Terms without it on the other, so add over the x. Okay, when I look at this, they aren't like terms, so I can't actually subtract them. What can we do? We're trying to get y by itself, so if we take out the y. So y is 2 plus x over x minus 3. The last thing we did was change it back into function notation. So we changed the y to f inverse of x. That's just notation to show that we found the inverse. And then we did domains and ranges. The domain of the function, the x's in the original become the y's. So that is the same as the range of the inverse. The range of the original function, the y's in the original become the x's or the domain of the inverse. So what we did is we usually found domains. Domain of the function. If I look back at my original function, we know in a fraction the bottom can't be 0. So x can't be what? 1. So we would say negative infinity to 1, union 1 to infinity. The range is harder to tell without a graph, so we did the domain of the inverse. We look at the inverse, what can x not be? 3. So that's negative infinity